Welcome, software engineers. Happy Wednesday. It's good to see you, at least logically and virtually there. I wonder if I have something set up. You've done polls before, maybe on Zoom, or maybe you haven't. So maybe this is a good way to do it. I should have done this a little more. Some folks are always. If you see that poll, why don't you go ahead and take it now? If you're not familiar with polls in Zoom, I don't see who is answering in which way. They are anonymous. I can, however, see the results, how many people select which one. And when we're done with this, I'll let you know. So how much warmer is Irvine, California than Mequon, Wisconsin right now? Right now. You go ahead and do that while I read you the Dilbert. Someone told me you delegated all your projects to coworkers and told them the orders came from me. Yes, I started doing that 3 years ago. You can make that face all day long, but I'm not the one who hired all those gullible employees. Okay, some of you have done the poll. If you haven't done the poll, I'll leave it. Maybe we'll just go on a bit and we'll just leave that poll open for a little bit. And we can do it because I'm sure you know the answer to these questions. And even though I asked you these questions in exam one, they're still important. Maybe they'll show up again sometime in the future. Software engineering can be defined as management of the entire software development process. We've expanded what you might have thought management meant at the very beginning, so you know that it encompasses many things. According to the anonymous online employee survey, you don't trust management. What's up with that? Oh, right. And yeah, you can trust me here. The poll is anonymous. You didn't do this poll yet? Keep going. One more thing here. Oh, no. We got to do it. Sorry. We got to end that poll now. All right. I'll share the results with you. Maybe you can see them now. These were the guesses out there. Some people actually, maybe you knew. But yes, it is 40 degrees here. It's 90 degrees there. Oh, wait a minute. That's even more than 40 degrees, isn't it? Wow. Well, we might get back up to the 60s this weekend. Maybe. Thanks for doing that, folks. I appreciate it. If in your Zoom you see something about breakout rooms, hang on to that. I got to experiment and see if you can actually self-assemble into breakout rooms or not. But we'll do that later. Okay, so you can ignore any message about breakout rooms right now. Let's come back to my list of professionalism. Number 7 probably seems like an obvious one, being honest. Another characteristic or attribute of a professional is honest. Dilbert, your page layout is ugly. Tina, whose fault is that? I work in an ugly cubicle surrounded by ugly people. You trample on my sense of aesthetics and expect me to be unaffected? So it's my fault? You, your parents, your barber, and whoever dresses you. Sometimes there could be too much honesty. No surprise, I'm going to relate my aspects of professionalism to one of the commandments. 7th commandment, as identified by Lutherans following Martin Luther, you shall not steal. When we look at Luther's explanation of the commandments, I want you to focus on the positive that usually comes after the negative. We should fear and love God so we do not take our neighbor's money or possessions or get them in any dishonest way. But here comes the positive application. Help him to improve and protect his possessions and income. So beginning today, I'd like you to think about that in the CNCS assignment, where you'll relate the 7th commandment to the aspect of honesty and see how that relates to IT professionals. Pause. Computer science and information technology are certainly related. Sometimes people think about computer science as the academic discipline and information technology as the career or professional discipline. On most job search engines, if you type in computer science, you may or may not find anything. You type in information technology, and there are all the jobs that are applicable for us as computer science graduates. So I sometimes use CS, computer science, and IT, information technology, interchangeably. It boils down to this: we need to get more money from our customers. Hey, I've got an idea. Why don't we just break into their homes and steal from them? Unfortunately, he couldn't tell anyone why he won Employee of the Month. Well, sometimes it's obvious. Sorry. Last time I alerted you to this fact. Second exam, there are 3 units in CSC 222. This second unit, this middle unit, is on implementation, where we're focusing on design. And today we'll move on to instantiation. Exam 2 is a unit exam. It will just cover the material from this unit. That's happening a week from Monday. Is that right? It's not Monday, right? No, it's a week from Monday. It'll happen online at Blackboard. Same format, same kinds of questions that you saw in exam 1. The difference is there are actually different questions because they relate to this unit. And I'll have something posted on Blackboard soon, sort of some ideas and potential questions to think about to help focus your review for the exam. We can say more about that next week. I just didn't want it sneaking up on anybody. Well, speaking of sneaking up, there's nobody in this lab. Kind of gives me the creeps. I've mentioned this before, and on some of the assignments that you submitted, I may have mumbled in response. Have a good error message. Have you ever come across something like this that happened to me recently on Zoom? Well, something went wrong. As you can see, an error occurred while generating the items, and the error box that popped up said error. How useful. By definition, a good error message explains not only what went wrong, but what to do to correct it. Now, that could be a lot of work. You might think if I just say exactly what went wrong, that'd be good. And it's better than nothing. But put yourself in the user's shoes. Well, okay, yeah, that's what went wrong. How do I correct that? It could be fairly straightforward, like, please input an integer value. Okay, this is just chopped, of course, right? Error on the error. An error occurred while displaying the previous error. If your error message is error out, that's bad news. Bad news. All right. I'm trying to remember to always share this with you. Today, CNCS 7 is due. If you haven't yet submitted that, please do so. It's very helpful to me. I get some economy of scale when I can grade everything at once. And yeah, my stated horrible policy is I don't accept late assignments. If you contact me, I could bend that rule a little bit, but so much more helpful when you get things in on time. And the vast majority of you are doing that, so thank you. CNCS 8, just began talking about that right now. That's due next Wednesday. And the assignment I gave you last time, assignment 16, a team project, that proof of concept. That's what POC is, proof of concept, due next Monday. Let's chat some more about that near the end. I promised I'd show you one that I put together. maybe without some of the gory details involved, but just so you can see what I'm looking for there. Blackboard should tell you these things, but who knows? Onward. We have covered and discussed, and you've read quite a bit about design. Design is the heart of software engineering. But once you do design, we're not done. There's more to do. So the next major phase, the fourth major phase in software engineering is instantiation. I've told you before, I just like that word. I mean, it's a cool word, instantiation. If you can throw that out in a conversation, wow, yeah. Let's define what we mean by instantiation. Change the design into code. Succinctly, instantiation means change the design into code. So what are we doing? What are we creating? Lots of names for this stuff, right? In instantiation, we're creating the code, or we're creating the program, or we're creating the product, or we're creating the app. Lots of different names for what we're creating here. But changing the design into code means actually creating the runnable entity. Okay. Instantiation phase. Now, you in your career as a computer scientist at Concordia University, Irvine, and at other places, some of you, and even before that for a number of you, you've been coding for a while now. You've been doing instantiation for a while now. Even in this class, we've been instantiating since week 1. What's the purpose? Note that italicized adjective. The purpose of instantiation to create good code. Good code. So let's figure out what good code is, and then maybe some heuristics and rules of thumb for how to create good code. What do I mean by good? Well, you've heard this from me before. The transcendentals. The former president of Concordia University, Mequon, Dr. Pat Ferry, was big on these ideals. So I just rolled them into the class, okay? Did that endear me to the president? Did he give me a huge raise? No, but that's okay. I still think these are good ideas. What's good code? The first one, we'd all, yeah. If the code doesn't work, it's not good. That's the truth ideal. If the code works, it's good. If it doesn't work, it is not good. But many of us, that's the only thing we've thought about so far. There are other aspects of good code. This ideal of beauty, and we'll talk about that some today. The code needs to be understandable. Understandable to programmers, other programmers as part of the team, other programmers that may maintain this code later, and to me, a day after I make it. And a third ideal is goodness. Oops, I left off something we've talked about here. With goodness, not only should the code be efficient, in other words, we don't want the code to be unnecessarily slow. We want it to be good. And the other aspect of goodness that we have mentioned is good code is robust. The goodness ideal, one aspect of that is robust. That is, your code can deal with the unexpected. Your code's expecting the user to type in a float, a real value. Instead, the user types in a letter. Well, can you deal with that? Instead, the user types in a negative value. Can you deal with that? Good code does that. Truth, beauty, goodness. The fourth ideal is community. And in context, that relates to the user interface. We talked about some design characteristics last time of the user interface, giving a good user experience. That's part of it also. This seems like a dumb question. What would you expect from me? Oh, wait, can you hold on just a second? The nuclear reactor here is going critical. I need to plug something in to make sure that there. This seems like a dumb question. Why create code? But I want you to think about it deeply to point out some issues. At this point, a software engineer could legitimately say, we have a very detailed design. Isn't that good enough? Well, of course it's not good enough. Computers don't understand a design document. Absolutely. But don't forget, design is very detailed. Design doesn't just say sort. That's a what? Design says, it says exactly how to sort. Oh, yeah. When I was looking at assignment 14.5, some teams did a really great job of thinking up team names. Darn, I should have printed out this list. There was one about, this is not an acronym or something, and how I like acronyms. Well, it's not just me. Not just, all computer scientists like acronyms, right? And they're usually TLA, three-letter acronyms like CPUs. Sorry, ML is my abbreviation of machine language. The only thing a computer can execute is machine language. Binary form, the native tongue, the ones and zeros, that's how control units function. CPUs can only follow machine language. Now, why do I say that? HLL, which is another three-letter acronym, HLL is a high-level language. A high-level language, an example is C#, or any programming language you can think of or you've actually done. C# is for people. Computers don't understand C#. They don't understand all the symbols, the words, nothing. The only thing computers really understand is machine language. High-level language is for people. That's why in other courses you've heard about, and oh shoot, I forgot to double check this. You may have a course like we have at Mequon where we talk about program language translation, compilers, assemblers, interpreters, and other kinds of things. The purpose of Visual Studio, one of the major purposes of Visual Studio is to convert C# into machine language so that your computer can actually do it. It needs to be translated. You're saying so? The so is this. Well, not quite yet. Want some advice? Why? Can your ignorance and poor communication skills solve my uncertainty? You never know until you try. Sometimes you know. Oh. High-level languages are for people. Programmers, oftentimes we think, oh, C#, that's for a computer. No, C# is for people. Computers don't get C#. It has to be translated. All right. So what that means is we're going to think about a high-level language primarily for people to understand. Wow. I mean, that's a That's a radical idea. Not so radical because almost every organization you look at will have professional coding standards. I worked for Hewlett-Packard Corporation. We had a big book with, oh yeah, that shows how old I am. We actually had a book. It had an orange cover. It was called the Orange Book. It was all about, here's how we create code at Hewlett-Packard. And it wasn't, here's how to learn how to program. It was, here are the professional coding practices and conventions. Again, since a high-level language like C# is for people, it needs to follow a coding style. In English classes, you've probably come across style guides. If you create a research paper, you may have to follow APA, MLA, Turabian, and other style guides there for citations. And of course, there are other style guides to tell you, here's how to create an understandable paper, topic sentence, body of a paragraph, et cetera, et cetera. Coding style is that for programmers. Did I share with you before that I think you can find the answer to any technical question at a Microsoft website? They've got to have 300 trillion petabytes of information there. Okay, slight exaggeration, but serious, I think everything is there. The problem is sometimes trying to find it. Here is an article on C# coding conventions. Coding conventions serve the following purposes. They create a consistent look to the code so that readers can focus on content. It's not for the computer, it's for people. They enable readers to understand the code more quickly by making assumptions based on previous experience. Yeah. They facilitate copying, changing, and maintaining the code done by readers. The computer doesn't care about any of this stuff. Naming conventions, Pascal case versus, what do they call? Camel case. Different organizations have different names for these things. Pascal case is just capitalizing the first word of every word you slam together in order to make something. You see it here like physical address, etc. Yeah, the point is not so much which case, which naming convention you follow, but that you are consistent with your organization. That way, when you pick up somebody else's code, it makes sense. When somebody else picks up your code, they say, I know what's going on here. Good. Additional naming, layout conventions. Write only one statement per line. The compiler doesn't care. You've got statement terminators and separators. You got semicolon. You could throw everything on one line. People reading it care. Write only one declaration per line. Add at least one blank line between method definitions and property definitions. Use parentheses to make clauses apparent. And again, sometimes parentheses are not required. Commenting conventions. Place a comment on a separate line, not at the end of the line of code. Begin comment text with an uppercase letter. End it with a period. In other words, write it like a sentence. Insert one space between the comment delimiter. Don't create formatted blocks of asterisks around comments. Ensure all public members have the necessary yes. String. Okay. And it's going to go on and on for a little bit here. Most organizations that I'm familiar with have professional coding standards, guidelines that they want all of their software engineers and programmers to follow. Why? you've already figured out that I say something more than once. It's probably important and oftentimes finds its way on the exam. High-level language is read by people. It's not for computers. People are going to read C#. You must be able to understand the code that is written in the high-level language. Why do you need to understand it? You, as the instantiator, will want to verify it. You can't verify the code unless it's understandable. And it will need to be maintained at some point in the future by you or by somebody else. If it's understandable, it's easier to maintain. All right. So what are the guidelines? These are not algorithms. These are heuristics. What are the guidelines? Not following these doesn't necessarily mean your code is bad. Sometimes following these doesn't necessarily give us really good code, but these are the guidelines, standards. And you saw those at the Microsoft style guide, like naming conventions. In general, we give methods a verby-like name, compute something. We give structs nouny type names to indicate what the structure holds, student record. Thank you. The use of identifiers. An identifier is anything that the programmer can name. Not keywords, right? You can't call an identifier if, but anything else, a variable, a constant, an object, method, function, they had to be named. Avoid one-character variable names. Avoid one-character identifiers. If you look at your code and it's all X, S, T, I, etc., you're not doing it right. You say, it takes too long to type in miles per gallon. Can't I just type in X? Well, you can. And again, the computer could care less because to the computer, identifiers are just memory addresses. They don't know names. But the other person reading your code may wonder, what in the world is X? So if you say, okay, it's not one character, it's R2D2. Make it meaningful. Again, if it's supposed to hold data, that oftentimes has a noun type of name, like weight. In the last, I don't know, number of years, software engineers, programmers have really discussed, and many have adopted and embraced a readable style. That includes things like white space. White space is just what you see here. Space in between and space before and after, etc. For many programming languages, you don't have to put a space between things. Compiler doesn't care. You have the space there so we can read it. Imagine reading a book that we didn't have a lot of white space in. You go, oh, this is hard. It's not very readable. Indentation. Now, in Python and other languages, indentation is required. The designers said, hey, we're going to force people to have readable style. But in others, C#, you don't have to have indentation. It's helpful. It shows you control structures. It helps you easily identify things. Comments. Creating good comments is hard. My Heuristic and guideline to you since week 1 was a good comment explains why and not what. And in context, that's an inline comment. The main comment in every object should explain what. Who is the programmer? What's the date? And what does this thing do? But when you have inline comments, you don't have to have a comment by an assignment statement saying, hey, we're multiplying values here. I think we can understand that. If it's not obvious and you want to ensure that people get it, have a comment there explaining why you are doing what you're doing. There's lots of other things. You can read more about it. The use of constants, etc. Yeah. But I think that if we can really focus on those first 4 ones, we're doing great. We're doing very well. You may not recall the name John Sculley. He was the CEO of Apple some time ago. John Sculley was the CEO of PepsiCo and then became the CEO of Apple. And then I don't know where he went. But a number of things, I don't want to say, well, yeah, surprised him. He wrote this: at Apple, even software has to be beautiful. Even code has to be beautiful. And Sculley was just, talking to software engineers. It wasn't just that their code worked, truth. It had to be beautiful code. People would go in and admire it. Oh, okay, maybe that's over the top. It's like a writer. People would look at somebody's style. They would look at their code writing style. Yep, it's important in organizations. Let's look at one of these, since I took the time to find them, and then we'll stand up. What? Oh man, what happened there? Okay. Well, it's going nowhere. Let's do the second one. I really want to show that one. Article in Lifehacker. Yeah, I'm sure we could believe everything they say. What it really takes to be a professional programmer. A lot more to professional programming than writing code. Thank you. From working with a team to solve problems to version control, you won't make it to the major leagues without a toolkit of other critical skills. By the way, all this is the aspects of professionalism, working as part of a team, working in a team. And really, we can sum up this first paragraph with our word, management. Can you manage yourself? Can you manage others? Can you manage versions? Can you manage, etc.? Professional developers. It's easy to think that knowing a programming language is all it takes. Yeah, a little bit more, okay? What's this author say? Learn to communicate. Absolutely. Software engineering, part of professionalism is, we already talked about being civil. Communication. Can you work well with others? Problem-solving skills. One of the reasons that college professors make college students do lots of assignments is to practice problem solving. Wouldn't it be cool if you could just read a book and then be a competent problem solver? Or maybe just sit back and watch other people solve problems, and then you know how to do it. Or put in your earbuds and go to sleep at night subliminally. You know, Siri would change you into a great problem solver. The only known method of brushing up on your problem solving skills is to actually solve problems. Oh, you're welcome. Version control. Yeah, we should have done that. Yeah. I mean, rather than going through Blackboard, we should have done GitHub. I got to double check. Do you do GitHub? You probably do. Develop a knack for learning. Technology is always changing. Really? We're not still using COBOL? So should a developer's knowledge base. You want to stay relevant, it's important to keep up. Keep up. A lot of others. And, you know, I think I've forced many of you to learn some new things here in the context of Visual Studio. And that's hard. You've had to, I don't know, you're going to have to experiment, investigate, look things up. Yeah, it's a lot of work. All right, are you ready? Would you like to stand up? Sure you would. Let's not read that yet. Okay, let's stand up. The department chair at Concordia University, Wisconsin, Dr. Mike Littman, always, the running gag is he claims he's not wearing pants. So every time I stand up, I want to say, oops, I'm not wearing any pants. I actually am. Okay? So maybe I won't do, but if you hear me say that accidentally, it's because you just are not familiar with the strange people at our campus. All right, are you ready? Stand up, take a break. It disappeared. Walk around for 1 minute and then come back. Are you standing up? I'll come back. I want to find that first article. I'm not sure where my link went there. We'll look at that, but we'll do that some other time. This is a name that computer scientists should have heard of. I don't mean you should already know him now, but at some point in your college career, you should be exposed to Don Knuth. Don Knuth is sort of like the father of modern computer science, professor emeritus at Stanford University, wrote a series of classic books called The Art of Programming, kind of the computer scientist. The first thing I would say is that when you write a program, think of it primarily as a work of literature. You're trying to write something that human beings are going to read, not something for the computer to follow. The more effective you are at making your program readable, the more effective it's going to be. You'll understand it today. You'll understand it next week, and your successors are going to maintain and modify it, will understand it. Wise words. Readable? Yeah. All right. Last time I said, if you wanted to instantiate, if you wanted to create code from specifications, that's hard. And then we looked at some design, and it was easier. Well, PDL, The acronym stands for Program Description Language. PDL is pseudocode, not real code, but fake or false code. In other words, it's something that looks like a programming language without having to worry about all the syntax and semantics of a programming language. This is design. This is design. If I asked you to instantiate this from design, could you do it? Yes, you could. Here's another one. The point of this is people write PDL in different ways. There's no, other than your organization may have a standard, there's no global standard for pseudocode or PDL. It is precise English, but it's not a programming language. So here's another one. This is an algorithm. It's the algorithm to compute the greatest common divisor. Now, doesn't look quite as, this kind of looks a little better, a little more depth and detail here. This leaves some things open to determination. If you look at the bottom of step 3A, you see it says repeat at step 2. So I'm going to repeat steps 2 and 3. Now, if you're the programmer going to instantiate this, you know how to repeat, or do you? What looping constructs could you use? In general, you know that there are several different constructs that allow me to loop. We could use a classic while, the so-called pre-test conditional loop, or we could use a counting-based loop, a for, or we could use a conditional post-test loop, maybe in our language identified as a do while. And other languages have more looping constructs. So let me go back a slide. The question is, see this repeated step 2? How am I going to do that? I know that as a programmer, I could instantiate a loop in several different ways. I could conceivably use any of those. But the question is, which construct would you use to solve this problem? And remember, it's got to be accurate, it's got to be truthful, it's got to be efficient, it's got to be beautiful. Okay. All right. Well, we're not going to do it. Again, you're nice people. You're always nice to me. And I would not make you do this like I make the students on the Mequon campus do it right now. Write the C sharp. Write the C sharp to do that. Are you ready? Go. Good for you. Good for you. If you compare the instantiation to the design, you see that it follows the design. And you also notice that in this case, as a programmer, I had a little more work to do, right? The design didn't tell me which looping construct. So I chose the pretest conditional, the while, to do that. I think that works. You could try it out. There's a much better way to do it. Did you know there's some built-in arithmetic methods in our standard libraries? Did you know there's such a thing as greatest common divisor? There is. Okay, cool. By the way, big integer. Yeah, okay, we won't worry about that. But this is a much better way. I didn't have to write any code. Look, see this line? That's it. Let's go back here. This is a much better way. We'll assume that the code library is correct. and good and yeah. All right. Much better. See how happy those people are? Speaking of happy people, Zeb is married to Martha. Zeke is married to Mabel. Zeb, I told Martha to meet me at the gym. Zeke looks at his watch. What the heck? What are you doing here? Why did you stand her up? Zeb, well, the two of us are not going to work out. The two of us are not going to work out. I'm really trying here. Every once in a while, an A student gives me a shout out in chat. Okay. How about this one? Chuck Norris, the early years. Well, this ain't going to work, is it? Good code is like a good joke. It needs no explanation. It's all there. If you pick up a listing, talking like they're on pieces of paper, if you look at a code listing and you do one of these and you wonder that's not good code. You don't have to ask somebody else. You don't have to reference anything else. The code is readable. In this class, I mentioned that testing is an activity that's done throughout the software development lifecycle. You can test specifications, you can test design, you can test requirements, and you could certainly test instantiation. Most of us, when we think of test, think of testing the code, executing the code with test cases to see what happens. But testing is done throughout the software development lifecycle, and it's done in instantiation. Now, there are two types of testing. In general, validation. Validation is something that you do at the beginning of any phase. You ask yourself the question, am I doing the right thing? For example, at the beginning of instantiation, am I doing the right thing? How would I know? I will grab the design documentation. Remember, you're working in a team. You may not have done the design. Your task in the team may be the instantiation. So you're going to get the design documents, and that's going to tell you exactly what needs to be done. Validation up front. At the end of any phase or at the end of any intermediate portion of a phase, we do a process called verification. Verification happens afterwards, and verification asks the question, did I do the thing right? That's grammatically incorrect, but see, it's a playoff up front. Am I doing the right thing? Afterwards, did I do the thing right? Did I do it correctly? And here's where classic code testing comes in. I've created my code. Now I'm going to test it, give it test data, and see what happens. And you type it in and you get catastrophic error. User attempted to use program in the manner program was meant to be used. That's funny, right? Boss, I need you to do product testing for a new release. How could I possibly have time for all the work you keep giving me? Have you tried sacrificing your health? Do I look like I can run marathons? Yeah, I know. You feel like Dilbert because I keep piling it on. How? How do we do code testing? verification, testing after the fact. The first thing you need to realize is, like every other activity, it needs to be managed. Software engineering is about managing. We'll manage testing by having a plan. We plan in every other phase. We're going to have a plan in this phase also. The plan of how to go about testing. Just running your program is not testing. Running your program and picking random numbers out of the air, putting it in and seeing what happens, that's not testing. Testing, like every other activity, needs management. You've got to create a plan. If you don't plan your testing, you will be fooled by correct looking output. You won't know whether the app is really working or not. When I've run all of your assignments, 0, 4, 7, 11, and 13, I have an actual test plan. I put in these values, 0.1, 0.2, 0.3, 0.4, 0.5, undo, 0.7, etc. Go through a couple different steps, and then I look and see how many shims does it say you have and what's the total? And I don't have to guess. I've got it written down. You have to plan testing. How do you do that? You develop what are called test cases. A test case, simplistically, is the input data and the expected output. The input data you're going to give to the app and the expected output I'll get from it. You have to plan your testing. In a larger scale, we think about something called traceability. Traceability says we'll link each feature or function from the requirements to the specifications to the design to the instantiation to test. We'll have a chart that shows, hey, every feature, here it is in the specs, here it is in the design, here it is in the code, here it is in the test. I'm even wondering myself how this relates, other than it is a list. Here's what I mean. Here's a traceability matrix. The requirements for our add number said to add numbers, okay? Where is that found in the specifications? Produce a running total of shim weights. Where's that found in design? Update the running total to the running total plus the most recent input. Where is that found in the code? There it is. Now, for every feature and function, we would show, hey, from the requirements to the specifications to the design to the code, here it is. And then what I haven't shown you is, how do I test that? Well, that's the test plan that we will get to. Are we going to be able to do this? Well, let's see if we do. I did enjoy, thank you for a couple folks. You need to get assignment 14.5 to me. Get that really, really quickly. I enjoyed reading the interesting fact. Wow, you folks are really interesting. I'm supposed to have 3, but I only think of 2. Number 1, I was born in California. I was born in Sacramento, California. I spent most summers in El Cajon, California. That's San Diego suburb. And I worked in Cupertino and Sunnyvale, California. So there's the Golden State. And look, here are you guys down there. Cool. Oh, by the way, third interesting fact. I'll tell you this one in a second. My wife and I have driven all of Route 66, not at the same time, but we've been on, well, in some places, Route 66, you know, is divided up into what years. But anyway, we've been on a portion of Route 66 in every state, from Chicago, Illinois, through Santa Monica, California. Third interesting fact is, naturally, without correction, I cannot see very well. I wear contact lenses. Without my contact lenses, my vision is 2400. What does that mean? That means that on the eye chart, I can see the big E. And the only reason I can see the big E is because it's always a big E. If they made it anything else, I might not be able to pick it. Anybody out there? No, I can see you now. Good. All right. A couple of things we need to do. First of all, let me say some things about homework assignment 16. Homework assignment 16, the hard part is the management. You have to figure out what an API is, find one, and then how do I connect it to my Visual Studio project? That's the hard part there. Let me see. Let's go here. Okay. Let me show you mine. I'm just going to run it, and then I'll show you the code. Okay, let's run mine. Are you ready? Sure hope this works. Zoom is kind of a resource hog, but anyway, here we go. Okay. So the API that I found was the I forget well, we'll look up the name of it in a minute, but it will basically give you a joke in a category, right? So notice, I didn't even give my form a good name. You're just doing a proof of concept. Notice that there's just two, there's a big output box here. There's a huge button. It's going to do one thing. When I press the button, now there's a whole bunch of additional stuff there. I was going to get rid of that, but I wanted to check some things and I forgot to do that. Here's the joke, okay? Why did the ghost go inside the bar? For the booze. If you laugh at that and not my jokes, you're in serious trouble. So what's happening here? When I click get a joke, my app is sending a request to the API of this far distant server, and then it's returning. I hope I got all these okay. Can I tell you a TCP joke? Please tell me a TCP joke. Okay, I'll tell you a TCP joke. Transmission control. Okay, all right. Well, some of them are certainly better than others, but there you go. Doesn't have to be long involved. I'm just looking to see, can you make a connection to any other API somewhere? All right, let's look at the code. I wonder what all this stuff is. Okay, I don't know. It might be something there. Who knows? But if you look, I mean, there's not a lot of code here, right? Where are we going? Well, here it is. This is just all part of what the API says to do. So, get it, set it up, get it, display it. Not a lot of code. But the code that's there is difficult. You have to think about it. There's a tiny bit of error checking here, not a lot, just this if statement, basically. And I'm not as concerned about that. Just making the connection to the API. So that's your task. Now, I want you to do this as a team. I want folks, members of the team, to all be involved. And it's okay if one person of the team knows some things and is doing a little bit more, that's fine. It'd be impossible to divide this 25, 25, 25, 25. But I want to ensure that all members of the team are involved with the process. And when you're all done, everybody should understand what happened. So if you're on that team and you don't know exactly what that code is doing, ask. I'm saying to do that. So it's okay. Do you don't know what's happening? If somebody else just took the bull by the horns and threw something in there and did, here it is. Be sure you ask so you know what's going on there. Did anybody try to go to that Azure Hub or whatever it was called and see if you can actually connect and download any Microsoft product, especially Windows? Anybody try that?
My team got to the website, but wasn't able to actually implement any of the code yet.
Okay. Okay, great. Thank you. All right. Let's do something different, shall we? Some of the teams you gave, oh, I'm sorry. Some of you folks don't know how to spell your name. I'm sorry. I just, by the way, I know if you're, Maggie instead of Mark, I'm just grabbing these out of the roster. Some of you had a number of suggestions for a team name. Others of you picked one. I haven't updated this yet. At some point in time, you can do that. But this is what I want to experiment with. We still have 8 minutes in the class, so we got plenty of time to do this. Now, I know not everybody is here, and some folks have a legitimate excuse. I know that there are a couple folks that have a course conflict on a day, and I said, that's fine. I know at least one individual sent me a note, I'm sick today. That's fine. So for those of you that are here, I want you to tell me, go to the breakout room. Close though. They should be open. And I haven't tried this before in Zoom, but the latest incarnation of Zoom says that you can choose which breakout room to go to. So, let's see. Now I got to find you on both lists. I just see Frank on here. Okay, so Frank is part of Team V. He should be able to go to the breakout room and say, I want to go into the Team V breakout room. And the same with everybody else that's here. Ryan, your Team T, you should be able to assign yourself to the breakout room that is named Team T. Would you please try that right now? Okay. I'd like to see everybody get into a room. And once you're in the room, you can wait there. I'm going to broadcast a message to everybody in the room once I see everybody is in a room. So if you don't know how to do that, I'd love to show you, but the host is different and I can't show you where the breakout room button is. I don't know if it's under participant. You should probably have just a button somewhere that says breakout room.
I just tested it out. I was able to jump in and then leave, and it just brings you right back to here afterwards.
Great. Thank you, Kyle. Everybody jump in right now because I want to broadcast a message to all. For those of you that have jumped back, you can hear me. I don't think you can necessarily hear me when you are in the breakout room proper. But I issued a message to close out all the breakout rooms. Fortunately, Zoom gives us a 60-second time frame to do that. So, okay. Oh, here it is. Good. All right. Oh, shoot. Where? I was going to jump into Blackboard, but I don't have Blackboard set up here. Okay. Well, we won't do that. We'll go back. We'll just sit here for a minute. So if you're all back here and it looks like at least Zoom is telling me you are, what I'll try to do from time to time is to have this available. As a matter of fact, I just want to say one other thing, and then I'm going to ask you to jump back in the last couple minutes, jump back into your team meeting room here. And just among yourselves, you can chat among yourselves, just figure out when you're going to meet next, especially when to take a look at assignment 16. And if for some reason you haven't submitted 14.5 yet, you need to do that. All righty. Okay. So again, in assignment 16.5, the one other thing that you didn't see, and yes, I need you to send me your entire project folder. Just zip it up. So what you're going to upload Monday, and only one person of the team needs to do that. I'm going to suggest the team lead do that, but it doesn't have to be. So just one person on the team needs to upload assignment 16. Be sure that in the comments, in the code comments, you've listed everybody on the team. I mean, I do know too, but that's helpful. And one other thing you need is you need a document in there. So just at the root level here, just have a document that explains, here's the API that I found, here's how I connected it to Visual Studio, my project, here's how I used it, etc. Doesn't have to be long and involved, but just some documentation that could potentially help somebody else understand what's going on there. So teams work together, create this proof of concept, which is assignment 16. Once you have it, then just zip up that entire project folder and upload that. Just having the executable in the code won't help me, right? I need to see the other things that you've added in, the connections to the API. Any questions or comments or concerns about that?
Is there any way you could post that to Blackboard?
Yes, I think it is on Blackboard. What I just said?
Yeah, I haven't looked. Sorry.
Okay, yeah, no problem. Yep, that should be there on Blackboard. So double check that. You bet. Yeah. Folks, I know we're pushing right up against it. I show just 2 minutes left, but what I'd like you to do is I would like you to jump back into the breakout room with your other teammates and then just decide, when we meet next, how we doing this, email, whatever, just so you're all on the same page, because you'll need to be working on this before Monday. So what I'm going to do, I'm going to stop the recording, but before I do, have a nice day. Have a happy rest of the week and weekend. I'll see you on Monday.